Hello, this is Math 2134 coming to you from the College of DuPage for the fall of 2020. The title of this lecture is Lines and Such. The slope of a non-vertical line is described here. So if the first point x1, y1 shown here and x2, y2 shown here are any two distinct points on a non-vertical line, the slope m of L is given by m is equal to the change in y over the change in x. And if you look at this, you see that's going to be the ratio of y2 minus y1 over x2 minus x1. And every line has a slope. Here you see a positive slope, the blue one, because when x increases by 1, y increases by 2. The red line here has a slope of minus 1 because when x increases by 1, y decreases by 1. And here you see that there can be many lines with a given slope going through a point like 0, 0. We're going to see that a point and a slope uniquely determine the line. So here's example 1. I'm asking you to sketch the straight line that passes through the point minus 2, 5 and a slope of minus 4 over 3. You know what to do. Let's see how you did. So you have to go through the point minus 2, 5, and then the slope is to be minus 4 over 3. So if x goes plus 3, then y goes down 4. So your next point is going to be, if you add 3 to the x coordinate, you get 1, and if you subtract 4 from the y coordinate, you get 1. So the other point is 1, 1. 2 points determine a line, and we draw the line through those 2 points. Example 2 asks you to find the slope m of the line that passes through these 2 points. You know what to do. Let's see how you did. Well, you pick one of them to be the first point. It's going to be minus 1, 1, and the other one to be the second point. It really doesn't matter which you pick to be which. And then we use the formula. M is equal to y2 minus y1 over x2 minus x1. We do the formula. Notice that when x1 is minus 1, we have a minus. That gives us a plus, so that is going to be 6. This is going to be 2. 2 over 6 in lowest terms is 1 over 3. Again, it doesn't matter which one you pick to be the first point and which one you pick to be the second point. Here I'm asking you to find the slope of the line that passes through the points minus 2, 5 and 3, 5. You know what to do. Let's see how you did. And you pick the points this way, and you subtract, and you find the slope is 0. When you look at the graph, you see that since the y coordinate is the same on both of these, it is a horizontal line. In general, the slope of a horizontal line is going to be 0. We can use the slope of a straight line to determine whether the line is parallel to another line. Two distinct lines are parallel if and only if their slopes are equal, or their slopes are undefined. And that means that there is a 0 in the denominator. So here's an example. You have one line that passes through these 2 points, and a second line passing through these 2 points. Determine if the lines 1 and 2 are parallel or not. You know what to do. Let's see how you did. So you calculate the slope of L1, you get minus 2. The slope of L2, you get minus 2. That means they have the same slope. That means they are parallel lines. So we can use formula 3, which was our slope, m equal y2 minus y1 over x2 minus x1. But if we take xy to be a general point on that line, and we know that the slope of the line determines The line we're talking about going through a specific point and a slope. So this is called the point-slope form of the equation of a line. An equation of a line that has slope m and passes through the fixed point x1, y1 is given by y minus the y coordinate is equal to m times parentheses x minus the x coordinate. Again, since we have a point and a slope, this is called the point-slope equation of a line. Here's an example. Find an equation of a line that passes through this point and has slope 2. You know what to do. Let's see how you did. So we will take the point as 1 and 3. The slope is 2. So it's y minus the y coordinate is equal to 2 times x minus the x coordinate. This is the general formula we're using. And we distribute and simplify, and we can get the equation to look like this. But there's a unique equation of a line and a unique line that passes through a point with a given slope. Example 6. Find an equation of a line that passes through these 2 points, minus 3, 2, and 4, minus 1. You know what to do. And when we continue in 6.1, we'll see how you did.